In this next video, we're going to think a little bit about the basic controls that you have available to manipulate structures within the RasMol software. If you followed the instructions in the earlier video, you would have downloaded a copy of the RasMol package, which will be showing up as a RasWin file, short for RasMol for Windows. And as I hinted earlier on, unfortunately, RasMol is no longer compatible with the latest operating systems for Macintoshes. Now, to open the package, we are as normal going to double click on that. And when we do so, we see a black window here with some pull down menus at the top. What we don't see is the fact that actually there is a second opportunity for controls, and that is the so-called command line. So we need to go down to the RasMol symbol in the bottom toolbar and open the separate command window screen. Now we're going to maneuver these around on our screen so that we can maximize the space that's available in the viewing window, the black window here. So I'm going to just maneuver this around, stretch from the corner, maybe even reduce the command line even further, just so that I can open up and make a large square window there. So to show how the package works, we then need to import a protein file of some sort. And in the previous video, I started by going to the protein data bank, and we downloaded the file for a COVID spike protein. So that's available. I've saved that in a folder that I have here, so I could drag and drop that into the window. Or alternatively, I can open the windows in the way that you might normally expect to do. Go to File, Open, and then the file was 6xm4, and open that within our window. When we do so, whenever we import a file, it opens in this so-called wireframe view, and that's pretty confusing. Certainly if you're not used to looking at these kind of structures, most of us, myself included, would tell very little from looking at that to begin with. So we want to be able to view it in a way that's more user-friendly. And so the first place we're going to turn, and actually in this particular video we're only going to think about the display menu and the colors menu. If we go to the display menu, we can put it into backbone, and we can see it still looks like a huge ball of wool or a pile of spaghetti or something, although it's a simpler way of looking at things there. The most useful way in terms of simple first explanations is to look at the ribbon view. And so you can see there that's in a monochrome setting, but we can start to see some shapes appearing. The other alternatives that we would have would be space fill, and that gives us a more realistic surface representation of the molecule, showing probably how it fits together in 3 dimensions. The ribbon view that we were seeing previously is a clearly simplified artistic impression, but it helps to show us where there are secondary structures. We can already see there's a section of beta sheet here, and there are a number of alpha helices present. Now, this type of view, the ribbons view, becomes all the more useful if we go to the color menu and add structure to that. And now we can see quite clearly the separate sections where we've got alpha helix and we've got beta sheet. And we can zoom in on this. So to zoom in, I'm going to hold down the shift key and then pull the mouse up the screen to zoom in, or down the screen to zoom out. And as I do so, we can see the detail there within this rather more clearly. Now, what's evident straight away is this is a relatively complicated protein. Even though we are only looking at a little bit of the COVID spike protein, it is nonetheless quite complicated. I can see that to some extent if I go back to my command line window, and if I type in show sequence, we can see the full sequence that's available there. And if I scroll back up that, we can see that actually that went all the way through to a serine at position 1147. So there would have been 1147 amino acids in that particular protein. If we go back up the sequence, we see that actually the particular structure that we have here starts with a proline at position 479. So we actually don't have the whole protein present, and that's often the case when you're looking at protein structures. For a variety of reasons, the whole of the protein may not be present. Nevertheless, this is quite a complicated situation here, and so what I want to do now is to actually close that file and go instead to a rather more straightforward protein. So again, I could drag and drop from the other window, but I'm going to go to open here, and I'm going to open a protein called ribonuclease. So once again, ribonuclease lands in the window. It's initially in the wireframe view here. I'm just going to look at this in the backbone view very briefly, so we can see that it's a much more straightforward protein here. If I go to the command line and I type in, let's go down to the bottom where I see the cursor. If I go to the bottom and type in show sequence now for this protein, what we can see is it's only 124 amino acids in length. So we start with the lysine 1 here and valine 124 here. And that's as far as I'm going to take in this particular video. I'm going to start again with the RasMol structure in our next video.